Hello everyone, I am Dr. Rebecca McKeeling. This is the first lesson of the course, Introduction to Probability. In this lesson, we will cover 3 topics: probability distribution, decision analysis, and utility and game theory by the end of this lesson. You will apply probability distributions in evaluating outcomes under uncertainty, analyze decision-making approaches using EMV expected utility and decision trees, and evaluate real-world business or economic situations using probability, decision analysis, utility, and game theory concepts. Let's start with Part 1, Probability Distribution. We begin by defining what a probability distribution is. A probability distribution is a function that gives the probabilities of occurrence of different possible outcomes in an experiment. We can think of a random experiment as a process that leads to an outcome that is subject to chance. Some examples of random experiments include flipping a coin, rolling a die, drawing a card from a deck of cards, and so on. The first type of probability distribution is common discrete probability distributions. Under this is the binomial distribution that describes variables with 2 possible outcomes. It estimates the probability distribution of the number of successes in n trials with p probability of success. Next is the discrete uniform distribution that describes events that have equal probabilities. Lastly is the Poisson distribution that describes count data. It gives the probability of an event happening k times within a given interval of time or space. The second type of probability distribution is the common continuous probability distributions, which deal with data that can take on an infinite number of possible values within a given range. One of the most well-known is the normal distribution, which describes data that cluster around the mean and become less probable the farther they are from it. This creates the familiar bell-shaped curve commonly seen in real-life scenarios such as SAT scores, where most students score around the average, while very low or very high scores are less common. Another type is the continuous uniform distribution, which describes situations where all values within a certain interval are equally likely. For instance, the amount of time cars wait at a red light can be modeled as uniform if the waiting time is equally likely to fall anywhere within a fixed interval. The log-normal distribution is another important type, which describes right-skewed data. It occurs when the logarithm of a variable follows a normal distribution, and a good example of this is the average body weight of different mammal species, where most species fall on the lower weight range, but a few very large mammals stretch the distribution to the right. Lastly, the exponential distribution is used to describe the time between independent events, where smaller values are more probable than larger ones. A classic example is the time between earthquakes, as shorter gaps are more common, while long intervals are less likely. Together, these 4 continuous distributions, normal, continuous uniform, log-normal, and exponential, provide powerful tools for modeling and understanding real-world phenomena. How to find the expected value and standard deviation. You can find the expected value and standard deviation of a probability distribution if you have a formula, sample, or probability table of the distribution. The expected value is another name for the mean of a distribution. It's often written as EX or micro. If you take a random sample of the distribution, you should expect the mean of the sample to be approximately equal to the expected value. Example case to analyze is Technova Inc., a mid-sized technology solutions provider. Is preparing to expand into Southeast Asia but faces several uncertainties that could affect its success. One key concern is market demand, whether customers in the region will adopt their product quickly or slowly. Another issue is investment risk, as the company must decide between establishing a wholly owned subsidiary, which involves higher costs but provides full control, or entering into a joint venture, which requires lower investment but means shared decision-making and control. Additionally, Technova must consider competitive pressure from Globutech, a major rival that may respond with aggressive pricing strategies or promotional campaigns to protect its market share. To address these challenges and guide its decision-making, Technova applies probability distribution models to measure uncertainty decision analysis, to evaluate possible strategies' utility theory to align choices with the company's risk preferences, and game theory to anticipate and prepare for competitor responses. This systematic approach allows Technova to navigate uncertainty more effectively and make informed strategic choices. First, let's compute the probability distribution by getting the data analysis from previous years or trend. This is the first-year sales forecast, then get the expected value. The expected value, also known as the mean, is the average value of a random variable if the experiment was repeated many times. To calculate the expected value, multiply each value by its probability and then add the products. The expected revenue for Technova's first year in Southeast Asia can be estimated using probability distribution. By weighting each demand scenario by its probability, the company arrives at an expected revenue of 36.5 million. This provides a more realistic forecast than relying on a single demand estimate, since it accounts for both upside and downside possibilities. How to apply this in research? Probability distributions are widely applied across different fields to model uncertainty and analyze data. In finance, for example, stock returns are often modeled using the normal distribution, as returns tend to cluster around the mean with fewer occurrences of extreme values. In operations research, the Poisson distribution is commonly used to model the number of customer arrivals within a given time frame, which helps businesses optimize staffing, service, and resource allocation. In the social sciences, survey responses can be analyzed using binomial probabilities, especially when measuring the likelihood of a specific outcome, such as yes or no answers or success versus failure responses. These applications demonstrate how probability distributions serve as powerful tools for simplifying complex real-world phenomena, allowing researchers to make predictions, test hypotheses, and support decision-making.